Okay, so we left off talking about empirical formulas, how to get the smallest whole number ratio, and we said we divide the each mole amount of each element by the smallest molar amount, and that gives us our whole number ratio here. Remember that we always assume if they don't tell us the total number of grams, we always assume that it's 100, and that's how we can get this. So we would assume that this is calcium hydroxide, and so that would be 13.5% calcium, which would mean 13.5 grams if we assume 100 grams. So if they don't tell you in the problem the total number of grams of that particular compound that you have, just always assume that it's 100, and that way you can use your percent composition. They'll give you one of the two. Okay. All right, so the next thing we're going to look at is molecular formulas. And like I said, we're going to be doing tons and tons of practice problems on these. And these videos are just like 5 minutes at a time. So we're going to watch them, and then we're going to be doing some practice problems too. So this seems like a lot that might be thrown at you, but you will get lots of practice in doing it. Okay, so let's move to molecular formulas and talk about those. All right, so in a molecular formula, we are looking for the actual amount, the actual number of moles or actual number of atoms in that particular compound. So it says, what's the molecular formula for a compound which has an empirical formula of CH4N? So remember, the empirical formula is the smallest whole number ratio. And what we're given is the molecular mass. We know its total number of grams for the entire compound. So we know the smallest whole number ratio. So then we can determine its molecular formula. So we're going to determine the formula mass, and the formula mass is just the mass of the empirical formula. Okay, so we have one carbon, so that's 12.01. We have four hydrogens, that's 4.0. And remember, these are atomic masses off the periodic table. And we have one nitrogen, which is 14.01. So when I add all of that up, it gives me the total for the empirical formula. Then I'm going to compare, all right, that's my empirical formula. I'm going to compare that to my actual molecular mass. Okay, so if I do that, I can see that my molecular mass is 60.12, but my empirical formula formula mass is 30.06. So when I do that, that's twice the size. Okay, so 30.06 divided into 60.12 is 2. So all that I need to do is take that number and multiply that number by my empirical formula. Okay, so 2 times 1 is 2, 2 times 4 is 8, and 2 times 1 is 2. So my molecular formula for this compound is C2H8N2. Okay, so for that, first you get your molecular mass, you find your formula mass, you divide divide the smaller one into the bigger one, divide the formula mass into the molecular mass, and then multiply that whole number, by the actual empirical formula. Okay. Composition of mixtures. This should be pretty self-explanatory as well. Mixtures contain molecules or formula units of two different types in varying proportions. So they're not things that are chemically bound together. It's two separate chemicals together in different proportions. Okay, elemental analysis can be used to determine the relative numbers of atoms in a substance and to determine its purity. So you can look and see how many different elements or how many different compounds are in a mixture, and that can help us determine its purity. So, all right, I think that's going to be a good place to stop for this video. Yeah. All right, that's it for that.